So let's go ahead and get started. This logic game can be found in Test 27, Section 2. It's the first logic game, so questions 1 through 6. And all we're going to do is just diagram this pretty straightforward game. We notice right away that it's an ordering game because the static variable are the 7 consecutive days in which buildings are going to be viewed. So all right, we're going to use our dashes, and there are 7 consecutive days, so we're just going to go ahead up here and we're going to put in our 7 dashes. Just like that. And of course we're going to number them. Just like that. And now we're going to apply our dynamic variables, which are given here as f, g, h. So let's go ahead and get that. And j, k, l, and m. Put those. And I'm going to make sure that I have all 7, and I do. And once I've made that brief check, I'm going to write the number 7 over here, going to circle it. And this is going to be my visual reminder that I have counted all the variables and made sure they match what the game gives me. It's just a way to prevent stupid mistakes that are very common. And with that, we're ready to turn to the rules. Now, I'm going to put my rules over here to the left. The reason I do that is because I don't want my rules directly underneath the diagram. I want to use this space if I need it for creating multiple boards or for doing other types of inferences. So I'm going to keep my main rules over here. And the first rule is a static rule. And a static rule is a rule that tells me where a variable is going to have to go. And static rules are going to often appear in my diagram because if it can be put in my master diagram, it must be put in my master diagram. So f used the site on day 3 or 5. We're going to put an f here. We're going to put an f here. We're going to make a little line to show us that it could go in either of those places. And next, another static variable, L views the site on neither day 4 or day 6. Now I'm going to write this down here underneath the diagram. I'm going to put it L at 4 and 6, and I'm going to negate it. And this tells me L can't be at 4 or 6. And I put it beneath the diagram because this provides a visual differentiation between positive positions of my variables and negations of those variables. So what's above tells me where things can go. What's below tells me where they can't go. Now I get 2 conditional rules, and you should already know how to diagram those just from having watched the logic videos that preceded these short series. If j is on day 1, then h is on day 2. So we go ahead and use subscripts here. And of course, we immediately take the contrapositive right underneath our original conditional by reversing. So h2, j1, we negate. We can just go ahead and negate each of those. Draw a line. So this says if h is not on day 2, j is not on day 1. And remember, everything on the left here cannot be together, but everything on the right can be. Now let's do our next conditional. If k is on day 4, then L is on day 5. Again, we immediately take the contrapositive by reversing L5, K4, negate, and then make our conditional. And then our last rule is a consecutive rule. And it says that G views the site on the day after H views the site. And we're going to craft this to look exactly as it would look in our diagram. H in front of G, and they're right next to each other to tell us visually that these are going to go in consecutive order. And now we're going to put a box around it. This tells us that they're a block, but it also tells us that this is the order in which they appear. Blocks always tell us H is going to be before G, and that's the order in which they appear. And with that, our diagram is done. It's clear, it's logically accurate, it's simple, and it's fast. So that's one game. We're going to take a look at another similar game. It's got some different rules and some different practices, and we're going to look at that in conjunction with this game right now. And our next game is in Test 26, Section 1. It's the first logic game, so it would be questions 1 through 7, and that's the game we're going to diagram right now. It's a little bit different, a little bit more complicated, but follows the same principles. So we have 8 physics students, and we know that that's going to be our dynamic variable, and they're going to be divided according to lab benches, and that's going to be our static variable. But what's unusual here is that our dynamic variable is split into categories. So 4 of them are majors, 4 of them are non-majors. So we're going to have to address how to deal with categories of variables instead of just having all of our variables together. We're also going to need to be mindful of who's given to what bench, right? In this case, it's very simple because our players to positions is equivalent. So we have 8 students, we have 4 benches, 2 students at each bench. So the 8 students are going to be divided among the 4 benches equally, 2 to a bench, and no student sits at more than 1 bench. So what does that look like visually? Well, let's go ahead and establish our benches. So we have a bench, and you can do this horizontally, but I prefer to do it vertically. So I'm going to draw 2 dashes, one here, one here. We're going to repeat this, and we're going to number it. Great. Now, we have majors and we have non-majors. Now, here's what I like to do with this. What I like to do is say, okay, M for majors, but I'm going to circle it. And the reason why I circle it is because I don't want to get confused and think that this is a variable. So I'm going to have an M and I'm going to circle it. The M stands obviously for major. I circle it because I don't want it to look like a variable to me. And next to that, I'm going to write F, G, H, and J. Now I'm going to go ahead and write N for non-majors. Circle that because I don't want to think it's a variable. And next to the non-majors, I'm going to write V, W, X, and Y. Now, I'm going to look back at my game. The very first rule gives me additional information about how people are being distributed, because that rule says exactly 1 major is assigned to each bench. So 4 majors, 1 major per bench. So my majors are going to be along the bottom, which means there are 4 non-majors, 1 to each bench, and those are going to be along the top. Now, here's an interesting thing about this diagram. That first rule, exactly 1 major is assigned to each bench, I don't need to represent that as a separate rule. It helps structure my game. So I'm putting it directly in my game in the way that I divide up my board. So M here for major, N here for non-major, and I can see immediately that I'm going to have a major and a non-major at each bench. Now, one of the things that can sometimes help is to go ahead and write the variables that will appear on the top next to them so that you have them visually right there available for you. Great. And now I'm going to pick up the remainder of my rules, and I'm going to again put those over here on the left side to keep things organized. This says F and J are assigned to consecutive benches, and that means that F, it says, is assigned to the lower numbered bench. And this is just a complicated way of saying that we have a consecutive rule where F and J are next to each other. F is going to be in front because it's a lower numbered bench. And we're just going to put a block around it just like we did in the last diagram to tell us F is immediately in front of J. And they go in that order where F is in the lower numbered bench. For now, I'm also just going to notice that F and J are both majors, and that really helps me because that means that F and J are going to be a block down here, and so G and H are always going to be separated somewhere. But I'm just noticing that. It's not part of my diagram yet. Now, the next rule says that F is assigned to the same bench as V. And remember, what we want to do is draw it how it would look in our diagram. And V is a non-major. F is a major. I have them stacked like this, so I'm going to put the V like this, I'm going to put the F like this, and I'm now going to put a box around these two here to tell me these two go together. V and F are together, and it looks like it would look on my board. And you can already see that V and F are going to go together, and then next to F is going to be J. And finally, our last rule, that G is not assigned to the same bench as Wanda. Now, I could do this as the same here, right? Because G is a major, W is a non-major. So I could do the same thing. I could put G here, I could put W here, do a little box around it, and then I could negate that. And that's fine. It accurately presents the rule. The problem is it doesn't look like it would look in my diagram. And when I'm thinking about having a visual representation of the information, I'd like the information to look like my diagram. And what it says on my diagram, the way it would look is that W and G would be in different benches. but I need some way to record that. So I'm going to record that by drawing a line between them and then putting a little X in it. And this says that W and G are on different benches. And now it looks like I would expect it to look, recognizing that W would be on top, G would be on the bottom. I don't need to worry about that. I just want to represent that they're on different benches, because that's going to help me when I set about trying to draw inferences and create a fuller picture of what's going on. And that's that diagram. That diagram is done. The takeaway here that's different from the other game is that we have to work on categories. So when we have to divide variables into categories, make sure that how you identify the category is distinct from what your variables look like. And also make sure that when you diagram, you are diagramming things the way that they're going to appear in your board. If you can do that, it's much better than something that's logically accurate like this, but isn't how it would appear in your board. And then finally, sometimes you're going to be given rules that you don't need to represent. You don't need to draw those rules, but they are going to structure how you put together your diagram.